Good morning, math friends, or afternoon, or whenever you are watching this. Today we are working on lesson 5.1. So we are starting a new module about rates and ratios. So today we are going to work on understanding what is a ratio, talking about the different ways that we can write them, and understanding what they mean. So we're going to work on writing a ratio in 3 different ways based on the situation today. So before you do anything, go ahead and start your Spark for Learning and try that out. Don't worry about doing the turn and talk, or because it wants you to actually talk to a person. You could tell me a different way that you could solve the problem instead of seeing if you and a partner use the same way. So see if you can think of a different way to come up with the same answer. So go ahead and do your Spark for Learning and then come back and see how I did mine. So we know that Jace and Kiko are each taking care of several birdhouses. Jace thinks that his birdhouses are more popular, but Kiko is disagreeing, and she's saying hers are more popular. So they decide to test their conjectures. They're both counting the number of birds that visit their birdhouses in one afternoon. Jace counted 12 birds that visit his 5 birdhouses, while Kiko had 15 birds that visited her 6 birdhouses. So we can't just say, oh, well, Kiko had 15 and that's more, because she had more birdhouses. So we've got to see if this pattern continues, and we've got to compare them. So one way you could do that is to set up a double table. So I have Jace's houses compared to the birds, and then Kiko's houses compared to the birds. So I know that if he has 5 birdhouses, that he's getting 12 birds. And she has 6 birdhouses that are getting 15. But their houses aren't the same. So I can't just say, oh, she has more. So if this pattern continued at the same constant rate, she would get 10 birdhouses, then she would make 15, 20, 25, 30. And Kiko would make 6, 12, 18, 24, 30, 36. So I can see that they both have the least common multiple of 30. So if they both built 30 birdhouses, then that would tell me who had more birds visiting their equal number of birdhouses. So 12, 24, 36, 48, 54, 60. So if she had 30 birdhouses, she would, whoops, I did some very terrible math right there. 40, I started counting by a totally different number here. So 48, 60, there we go, and 72. There we go. So if he had 30 birdhouses, he would have 72 birds visiting his birdhouses, and she would have 15, 30, 45, 60, 75. And I don't even need to keep going, because 30 is the number I'm wanting to compare. They both have 30 houses. He has 72, and she would get 75. So I am saying that Kiko's birdhouses are more popular because more birds are coming to visit her. So let's look at that another way. Let's make some fractions that we're going to compare here. So I know that I'm going to put a J out here so I can remember. Jace had 12 birds that came to his 5 birdhouses. And Kiko had 15 birds that came to her 6 birdhouses. So I'm going to make these mixed numbers so I can see how many holes they both have. So 5 goes into 12 2 times with 2/5 left over. 6 goes into 15 through 2 times with 3 6 left over, which is also 2.5. So I need to compare 2 2/5 to 2.5. So I know 2.5 as a decimal is 2.5. And I'm going to turn 2/5 into a decimal. So I put the 2 inside and the 5 outside to make this into a decimal. So 5 can't go into 2, but it can go into 24 times exactly. So this one is 2.4. 2.4 is less than 2.5. So again, I'm showing that Kiko has a more popular birdhouse style. So either way, I came up with the same answer, but I proved it mathematically in several ways. There are lots of other ways that you could think about this problem as well. You could have said that, let me get my pen here. I could have said I have 5 houses and 12 birds come for Jace, and Kiko has 6 houses that 15 birds come into. And I could have made the houses the same, and I could have skipped right to that number 30, to their least common multiple. And these are just like fractions. To get from 5 to 30 was times by 6. So 12 times 6 is 72. So he had 72 birds. 6 to get to 30 is times by 5. 15 times 5 is 75. She had 75 birds. Again, Kiko has more. Lots of ways to do that same problem and compare the rates at which their birds are coming. Okay, let's go ahead and look at task 1 here. So Tyree's cat has a litter of black and orange kittens. So this is a tape diagram. I like to think of it like I have a little tape dispenser and I'm pulling equal pieces of tape out. So the tape diagram shows the number of each color of kitten in the litter. Every section represents 1 kitten. So what are some different ways that Tyree can compare the number of kittens? So she has, I can see 1, 2, 3, 4 black kittens. Remember, every section represents 1 kitten. And then she has 1, 2 orange kittens. So let's answer some questions here. So how many black kittens? So I can see she has 4 sections. So that means there are 4 black kittens. How many orange? 1, 2. So now I want you to think about how many total kittens does she have? So nowhere on here does it just come out and say she has this many kittens total. How could you figure that out? So I want you to stop and think about that for a second. So I can see she has 4 black ones and 2 orange ones. And when I put that together, 4 black plus 2 orange equals 6 total. So now I want to think about what is this basic ratio. So every time she had 4 black ones, she had 2 orange ones. So basic means I can simplify it. So what can go into 4 and 2? So their greatest common factor is 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So every time she has 1 orange kitten, that means there's 2 black kittens. So let's go ahead and look at the questions for task 1 here and see if we can answer those with that information. Hey, so how many orange kittens are there? How many black kittens? So we've answered those, and now we're going to answer these questions. So there are blank orange kittens and blank black kittens. So how many? And then for every orange kitten, there are how many black ones. So this one is just how many orange, how many black. And then remember that simplified ratio, when we broke it down, every time we had 1 orange kitten, how many black ones were there? How does the total number of orange kittens, we're looking at our orange ones, which is 2. How does that compare to the total? So we've got to really pay attention and read the question to see what we're comparing. So we want to do orange to the total. So you can rewind the video if you need to check and see how many total or orange there were. So now it wants to know how many black kittens to the total number of kittens. So now we're comparing black to total. Hey, and then, so here's just showing us our picture again. Suppose each section of the tape diagram represents 2 kittens rather than 1. Will that change the comparisons in part A? So let's go take a look at that. So if we instead, I'm going to get rid of this. So every time there's a section, they said there were 2 kittens, and this would be 4, 6, 8. Here would be 2 and 4. So let's go ahead and answer these questions again. So how many black? 2, 4, 6, 8. How many orange? 2, 4. How many total? Well, I had 8 black ones and 4 orange ones makes 12. So then I have that ratio of 8 to 4. So I need a number that goes into both of those. When I do a double colon, dot, 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 that's like an equal sign. So 8 and 4 have a greatest common factor of 4. 8 divided by 4 is 2. 4 divided by 4 is 1. So because they have the same number of sections, it simplifies down to the same thing. Every time we have 1 orange kitten, we have 2 black ones. So let's see if we can answer those questions now. So if we had 2 in every section, how many orange kittens were there and how many black? But there are still 2 black kittens every time we have 1 orange one. So now suppose each section of the tape diagram represents 2. So we're still doing the same thing. So there are blank orange kittens in a litter of how many total kittens. This means there are still how many total kittens for every 2 orange kittens. So this wants us to compare our totals. So before we had 2 orange kittens to a total of 6. Now we have 4 orange kittens to a total of 12. So let's see, how do I get from 2 to 4 times by 2? 6 times 2 is 12. So these are equivalent ratios. They're the same thing. So we just need to simplify this to see how many orange kittens there are compared to the total. So every time I have 1 orange kitten, 2 divided by 2 is 1, 6 divided by 2 is 3. That means there's 3 total kittens. So we had 1 orange, 2 black, 1 plus 2 is 3 total. So we're just using our same simplified fractions to answer all these questions here. Hey, suppose the model represents a group of orange and black kittens with 16 orange. So if you had 16, but there was still just 2 sections. So 16 total orange. So how many would be in the first section and how many in the second? Have 2 orange sections. And then use that, and then that number, fill in how many black ones and see if you can find the total. If there are 16 orange kittens, so we're just using that same ratio to build on. So I know I want 16 here. So think about how can you get from 2 to 16 and do the same thing from 6 will tell you how many total kittens there were. So just using those equivalent ratios, we can answer all those questions. Okay, so we have this word ratio we've been talking about. When we're using ratios, we're really just comparing 2 numbers. So we just compared black to orange kittens. And it really is a division problem, and you can write it 3 different ways. You can write it with a colon to separate them. You can just write it as a fraction, or you can say the word to, A to B. So it can be written as 5 to 4, 5:4, which we say 5 to 4. They say the same thing, or 5/4. 5/4, 5 to 4. They all say the same thing. But notice every time the 5 came first, the 5 came first, the 5 came first. If it said that there were 5 blue marbles and 4 green marbles, blue came first. So we want to always keep it in that same order so that people reading the problem will understand that. So a ratio we can compare part to part, like we just did the black kittens to the orange kittens. We can compare parts to the wholes. So I could say there are this many orange kittens to the total kittens. Or we could do that backwards and say this is how many kittens there are. This is how many are orange. So all of these pieces are called terms. So let's do a little practice here. So we have a ratio of 6 oranges to 5 apples. So I want you to pause and see if you can write that in 3 different ways. So go ahead and do that and then come back and check. So I know oranges has to be first because that's what was given first. So I could say there are 6 oranges to 5 apples. I could say there are 6 oranges and just put the word to 5 apples. Or I could say there are 6 oranges to 5 apples. All of these mean the same thing, but notice I put oranges first every single time. Oranges came first to keep that ratio the same. So let's look at number 2 here. So Erin is making a quilt for a craft fair. The quilt is made with 4 different fabric colors as shown. So you can see blue, green, red, and white. So first we're going to draw a model to represent the blue squares to the white squares. So I want you just to count all of the blue squares and the white squares and see if you can draw some sort of model to represent that. There's lots of ways you could do that. So go ahead and do that. So I'm counting blue here, and I have 1, 2, 3 blue. So 1, 2, 3 blue. And then I've got white ones here. I'm going to use yellow to represent white. 1, 2, 3, 4, 5. So I could draw like a tape diagram and show 1, 2, 3, 4, 5. I could also just line those up and say there are 3 blue and there are 1, 2, 3, 4, 5 white. Either way, I'm showing 3 blues and 5 whites here. So we're going to write that ratio 3 different ways. So notice blue should come first compared to white. So see if you can write that ratio 3 different ways. So I know 3 blue, 5 white. 3 blue, 2 5 white, or 3 blue, 5 white. And now when I'm counting the total of blue and white, I have 3 plus 5 equals 8. So there are 8 squares that are blue or white, 3 to 5 squares here. So now we're going to write a ratio statement that compares any one color to the total. So first, I just want you to pick a color. So maybe you're going to pick green or red or blue or white. I don't care which one you pick, and count that color of squares. And then you need to count all the individual squares, big and small. Each one counts as 1. And see if you can write a ratio statement. So that means you're just writing a sentence about the numbers of them. So go ahead and try that out. So I'm going to try red here. So I know I have 1, 2, 3, 4 red. So I could say there are 4 red for to a total of, let's see, now I need my total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to a total of 15 squares. And I could do that same thing for the green. There are 1, 2, 3 green squares to a total of 15. So I can go through and do that for each one, but it wanted the single color first and the total second. So I could write that as a ratio and say 4 to 15, 4 to 15, or 4 fifteenths. Lots of ways to do the same information, a sentence, or 3 different ways to write a ratio. Okay, let's look at this problem here. So this says, for every large blue square, there are 2 small blue squares. So I have 1 large and 1, 2 small. So that sounds right. Every time I have 1 large one, there were 2 small ones. Does this mean that 1 out of every 2 blue squares is large? So this is saying if I have 1 big one, then I would also just have 1 small one. 1 out of 2 total is blue. But when I look at my picture, I have 1 big one and 2 small ones. So that means 1 out of every 1, 2, 3 is large. So this statement is not true. It would need to say 1 out of every 3 blue squares is large. So that statement was forgetting about, let me make that smaller. So this statement up here was forgetting about one of the blue squares. It was just saying 1, 2, but we've got 2 small ones, 1, 2, for 3 total. So let's see if we can go answer the questions on task 2 here. So here's just that model. So there are 8 total, 3 here, 5 here, 3 blue ones, and 5 white ones, which we drew a picture of. So now you're going to compare 3 to 5. Pick any of the statements that show blue first and white second. So you should be picking the 3 correct statements there. So every time we have a blue square, how many white squares? For every 3 blue squares, there are 5 white squares. And we can't simplify that anymore because 3 and 5 are already simplified. So now you're going to pick any that are true here. So it says select the statement. So anything that's true. So count the blue to the total, which we know was 15. The ratio of total squares to red. So total means there should be 15. So go ahead and see which of those are true. For every small green square, there are 2 large green squares. Let's see. 1 small, 2 big. So this says, does that mean that 1 out of every 2 small squares is green? So there are how many green squares? 1, 2, 3, and 1 of them is small. So 1 out of 3 should be small. Okay, so that is a little overview of rates and ratios. For the next several days, we're going to be exploring those deeper, looking at some different strategies, because there are lots of ways that you can get to the same answer. But we just need to understand that a ratio is telling us 2 things, and we can compare them 3 ways. And you can also compare part to part, whole to part, or part to whole. And you've got to read the statement to make sure you know which one should come first and what they're comparing. Hey, let me know if there's anything I can do to help you with this.